Chapter 4.4 Radical Expressions. Okay, before we learn the radical expressions, let's check the square of a number. Okay, the square of a number is you are multiplying the number twice. So the square of a number is equal to the number that is multiplied by itself. So 3 squared. So look at this one. This is 3 squared, right? So we read it as square of 3 or 3 squared. This means you are multiplying the base 3 twice. So you got the number 9. And this 9, the number 9 is called perfect square. Perfect square. So integers. So when you multiply, if you square an integer, let's start from 1. So 1 squared is equal to 1. Then 1 is a perfect square. And 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. So these numbers are called perfect squares. So perfect square is a square of a number. Square of a number, that is the perfect square. Even if you square a negative number, then the negative sign, negative times negative becomes positive. So the result is positive numbers, which is perfect square. So negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So these numbers are also same as the previous numbers, right? These numbers. So these are all perfect squares. So perfect square starts from 1, 4, 3, 16. 1 squared, 4 squared, 3 squared, 4 squared, 5 squared, and so on. So these are perfect squares. There are more, right? Infinitely many. So why we are learning perfect squares? Because we're going to use radical expression. So when you simplify a radical expression, we need a number that is a perfect square. Okay, so also note that squaring negative integers result in the same list of these perfect squares. Okay, so perfect squares are used. These numbers 1, 4, 9, all these numbers, all these perfect squares are used in simplifying square root. So the symbol for the square root is this one. Can you see this? This one is just like this. Draw like this and then like this. So this is a square root symbol. And so square root, let's say square root of 9. Square root of 9. Then there's a name. So this is the symbol. Square root symbol, right? Square root. This is the square root symbol of positive numbers. So 9 is a positive number, and this is called radicand. Okay, radicand. And this whole thing is called radical expression. Okay, so as you see the topic, radical expression. So radical expression contains the square root of a number. Okay, so how to simplify the square root? Okay, square root of a positive number x. So x is a number, positive number, and you take the square root. Then this is a number whose square is x. Okay, look at this. Okay, this expression. This is square root of x, right? Square root of x. And the result is what? It's a number. Let's say it's a number a. Then the result will be a squared. So a squared is x. So if a squared is x, then the square root of x is a. Can you see it? Something like this. So a is a Okay, a squared is x. So square root of x is equal to what? Square root of a squared, right? A squared. A is positive number, this is positive, right? So a squared is also positive. Then this is equal to what? A. Can you see this one? So square root of x is equal to square root of a squared. If x is equal to a squared, something like this, a squared, then this becomes these two, the exponent, the power 2 and the square root symbol cancel out. So what we have is only a. Okay, let's keep in mind that x is positive, and so that a squared is also positive, and a is positive too. Okay, so let's say a and x are positive. All right. So square root of 9. The square root of 9 is what? So 9 is 3 squared, right? 9 is 3 squared. So square root of 9. So let me write it again. Square root of 9 is 9 is 3 squared, right? 9 is 3 squared. So the square and square root symbol cancel out. This is the result. Okay, also don't get confused with this. Actually, negative 3 squared is also 9, right? 9. So square root of 9, then the 9 can be replaced by negative 3 squared. Then is the result negative 9? No. The result is positive 9. Okay? The result is not negative 3. I'm sorry, not negative 3. The result is positive 3. Make it positive. Because when you square this one, so negative 3 squared already become what? 9, right? 9, which is positive. So positive is square root of 3 squared again, right? So the result is 3, not negative 3. Okay, so always, if a is negative number, then make it positive. So actually, we can make this a positive. So what we need to do is put the absolute value around a. That is a, right? Make it positive a, positive a. So I think it's better to write. Anyway, a is positive. We assume a is positive. If it's negative, then make it positive. Okay. All right, so let's try more example. Okay, so square root of 1 over 9. Okay, what is 1 over 9? So 1 over 9 is, isn't it 1/3 squared? So 1/3 squared is equal to 1 over 9. Because 1 over 3 times 1 over 3 is 1/9, right? So if you keep this in mind, you can replace this 1 over 9. So 1 over 9 is a square of 1/3. So the result is what? 1/3, right? 1/3. Simple, isn't it? Very simple. So if the radical symbol, you have a radical symbol, and the radicand is a perfect square, then the result is the base. The base, and make the base positive. If the base is negative number, make the base positive. Okay, and then also look at this special case. Special case. Okay. Okay, special case is this. How about what is square root of 1? Okay. What is square root of 1? This is 1 because 1 is a perfect square, which is 1 squared, right? So that is equal to 1. How about square root of 0? 0 is also 0 because 0 times 0 is 0, right? So this is equal to 0. So always square root. If the square root contains a perfect square, then the base is the result. So make the base positive always. And then also, if you have a square root of negative number, let's say negative 3, then this is not a real number. Not a real number. Okay, not a real number. So you cannot put this one in the number line. So the number line does not contain a radical whose radicand is negative. Okay, always keep in mind this one. So we call it an imaginary number. This is an imaginary number. So for now, we will assume that the radicand is positive always. Okay, always positive. Okay, now evaluate square root of xy. Xy are variables and you are multiplying x and y. So when you evaluate this expression, the values of x and y are given, always given. So square root of xy. So replace this x and y variables with 5 and 20. So multiply 5 and 20, that is 100. And we know that 100 is a perfect square, which is 10 squared. So the answer will be 10. Okay, now simplify this subtraction. Alright, so let's simplify the square root first. So this is equal to, okay, square root of 36 is, so 36 is the perfect square. 6 squared, isn't it? 6 squared. So you can write it 6. Okay, let me write one more step. So 36 is 6 squared. So the result will be 6. And 9 remains the same. And 4 is a perfect square, which is 2 squared, right? So this is equal to 6 minus 9 times 2. So 6 minus, multiply first, 18. So the result will be negative 12. Make sense? Okay, then how about a square root of non-perfect square like 2? So 2 is not a perfect square. Then what would be the approximate numbers? You know, square root, now if the radicand is not a perfect square, then the radical expression is an irrational number. So irrational number means the number is, we can write this one in a decimal, but the decimal is non-terminating and non-repeating number. That is irrational number. So this is not a perfect square. Radicand is not a perfect square, right? Not a perfect square. So this means, okay, this is not a perfect square. So the results will be in irrational number. Irrational number. So irrational number means non-repeating number and non-terminating, right? Non-terminating. So if you use a calculator, then square root of 2 can be written as 1.41 and so on, like this. So this decimal is not repeating and it's not terminating. It goes, you know, forever. So let's make a square of the up to the 10th digit. So 1.4. What is 1.4 squared? You know, this one should be approximately equal to 2, right? 2 should be approximately equal to 2, because, okay, let's try 1.4 squared. That is 1.96, right? So it is not 2, but close to 2. Okay, let's square up to the nearest 10th, which is 1.41 squared. Then the result will be, use the calculator, then result will be 1.9881, right? Okay, it's getting close to the number 2. And let's square up to the nearest thousandth. So 1.414 squared. Then when you use calculator, it looks like 1.99 9,396, right? Okay, let's try one more time. Let's try 10,000th. So 1.4142 squared. Then it looks like 1.999, another 9, and 6164. So as you go further, the result will be close, very close to 2, right? 2. Okay. All right. So if the radican is not a perfect square, it's an irrational number, it does not terminate, it does not repeat. Okay, keep in mind this. Also, look at this, square root of 2. The radican is 2, right? Radican is 2. 2 is not a perfect square. What is the next perfect square to this number 2? Isn't it 4, right? 4. So 2, 3, 4, 5, 6. So 4 is the closest one. How about 1? So 1 is a perfect square that is less than this number, right? So when we square each number, what happens? Square root of 1, square root of 2, square root of 4, right? Square root of 4. So what is the result of this square root? This is 1, this square root of 2, and square root of 4 is 2, right? 2. So from this one, we can see that the square root of 2 is between 1 and 2, right? Between 1 and 2. Is it true? What's the value of the square root of 2? 1.4142 and so on, right? So this is definitely less than 2 and greater than 1. So when you find numbers that is whose number that is number is between those two numbers, then always use the square root. So find the closest perfect square and then take the square root so that you can find that square root is between two numbers. Okay, so let's check this one. Okay, between what two whole numbers is the value of 41, square root of 41? Okay, square root of 41 is not a perfect square, so let's check 41. Okay, what is the closest perfect square from this number 41? Isn't it 36 is one that is less than 41? Then 49 is the closest perfect square that is greater than 41, right? Okay, then take the square root for these three numbers. Okay, then from this one, when we simplify the square roots, 36 and 49 are perfect square, right? So this is 6, 41, square root of 41, and this is 7. So square root of 41 is between the whole numbers 6 and 7. Can you see it? So we don't know exact number of square root of 41, but we know where that number is between two whole numbers. Okay, let's try another example. Okay, square root of 10 is between what numbers? So the value of square root of 10 should be, okay, 10 is now greater than 9, right? 9 and less than 16. Because 9 is a perfect square that is less than 10, and 16 is a perfect square that is greater than 10, that is close to 10. So taking the square roots on each side, we can see that square root of 10 is greater than what? 3, less than 4. So square root of 10 should be equal to what? Approximately equal to 4 point something, right? 4 point something. So the exact value should be found by using a calculator, but it should be 3 point something, sorry, 3 point something. Okay, so this number, the square root of the value of square root of 10 is between what? Between 3 and 4. Okay, now simplify a radical expression. So simplest form. Okay, always radical expression must be simplified. So a radical expression is in simplest form when the radicand contains no factors. Contains no factor other than 1, that is a perfect square. What do you mean by this? So the radicand, if a radicand is a product of a perfect square, and so factors of a radicand is a perfect square, then that can be simplified. But if it's not, then it is in simplest form. So in this case, we need to understand the product property of square roots. Okay, we always have to apply this one. Let's say the radicand is positive, so a and b are positive numbers. Then square root of a times b. This is a product, right? Product. Then each factor can be separated by the same square roots. So this is a product, so you can make it a product. And then you can separate it, a and b, with the square root. Okay, which means square root of 4 times 9 is what? You can separate 4 and 9 with the square root. So square root of 4 times square root of 9. Then square root of 4 is 2, isn't it? 2, because 4 is 2 squared. 4 is a perfect square, which is 2 squared. So this is equal to 2, right? And then square root of 9 is 3. So that is 6. So we simplify the square root of 4 times 9. Also note, okay, also note that what is 4 times 9? 4 times 9 is 36, isn't it? And 36 is a perfect square, which is a 6 squared. So the answer is 6. In this case, we got the same result because the factors in this radicand are all perfect squares. Okay, how about this? What if we have a 50? Okay, let me erase this one. So what is the square root of 50? We know that 50 is not a perfect square. So let's separate it, this one, so that 50 can be written as a product of factors. So 50 is what? 2 times or 25 times 2, right? 2 times 25 or 2 times 25, right? Because we want to make a perfect, factorize, do the factorization so that if any factor is a perfect square, then we can simplify it. If a factor is not a perfect square, then leave it. So we can separate this to, okay, let me write 25 first because it doesn't matter, actually it doesn't matter. 25 times 2. Then we can separate 25 and 2, right? And 25 is a perfect square, so the result will be 5, right? 5. So that is 5 times square root of 2. And how about square root of 2? This is not a perfect square, so just leave it. We already simplified. So square root of 2 is in simplest form, so this is the result. So our results have one square root, and the other factor is what? Just a whole number, right? 5 times square root of 2. So the radicand is now simplified. We only have 50 became 2, right? 2. And 25 became just 5. Okay, how about square root of 48? Let's simplify this. Okay, 48 is a product of, okay, if we are not sure, then let's do the factorization. So 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. and 6 is 2 times 3, right? So this is 2 is multiplied 4 times, right? 2 times, this one is equal to 2 times 2 times 2 times 2 times 3. But if we can make this 2 as a 4, right? 4, which is 2 squared. So can we write it like this? 2 squared times this 2 is also 2 squared, right? And 3 stays as it is. So you can separate this one with what? Square root of 2 squared, square root of 2 squared times square root of 3. So this is 2 times 2 times square root of 3. Then finally 2 times 2 is 4 square root of 3. So 4 times square root of 3. So it is much easier to do the factorization and then make up back factors squared. So once it becomes squared, you can take out the base. Okay, or this is equal to what? Isn't it 16 times 3, right? 16 times 3. Then 16 is, you can separate 16 and 3. Then 16 is a perfect square. So 4 times square root of 3. So we got the same result. It doesn't matter, right? So if you see 48 is 16 times 3, then it's much easier. If you cannot see this product, then do the prime factorization. Do the prime factorization. So this one has a square, right? So you can take this 2 out, 2 out. Okay, 2 out, 2 out. And 3 remains inside the square root. Okay, for this application problem, the height is given 8 feet above the water. Then the range will be the result of this expression. So what you do is replace this h with 8. 8. Then r is equal to 1.4 times. You can use a calculator for this 8. So, okay, what is 8? Square root of 8. When you simplify this, 8 is 4 times 2, right? Then this is square root of 4 times square root of 2. So 2 times square root of 2. So you can write it as 2 times square root of 2, like this. So r is equal to 2.8 square root of 2. This point. Okay. Then r is approximately equal to, now square root of 2 is 1.41, right? 1.41. So when you multiply this, it looks like 3.96. This is an approximate. So use a calculator, then you got this number. So we can round this to the hundredth, right? So the range of the periscope is what? 3.96 miles. So in this particular question, just replace the variable with this value and then use the calculator. You don't have to simplify this. Alright, so this is the end of this section.